Hi dear friends, welcome back to our channel Anvinay Kumar Basics of Physics. Dear friends, in this video we are going to discuss about the one of the most important application of Gauss's law, and this is given in our textbook as long answer question number 1. So children, very easy one and most important question. ఇదే ఆన్సర్ నుంచి మనకి 8 మార్క్స్ అడిగిన సందర్భాలు ఉన్నాయి, డైరెక్ట్ 2 మార్క్స్ బిట్ అడిగిన సందర్భాలు ఉన్నాయి. సో కాబట్టి జాగ్రత్తగా చూడండి, వీడియోని స్కిప్ చేయకుండా లాస్ట్ వరకు చూడండి. ఇంకో విషయం, వీడియో చూసిన తర్వాత మీ యొక్క రెస్పాన్స్ని కామెంట్లో పోస్ట్ చేయడం మర్చిపోవద్దు. ఇంకో విషయం ఏంటంటే, మన ఛానల్లో ఇంటర్మీడియట్ ఫస్ట్ ఇయర్ సెకండ్ ఇయర్ సంబంధించినటువంటి ఐపీకి సంబంధించినటువంటి ప్రతి ఒక్క క్వశ్చన్ని, ప్రతి ఒక్క కాన్సెప్ట్ని అప్లోడ్ చేయడం జరుగుతుంది. అందుకే ఛానల్ సబ్స్క్రైబ్ చేసుకోండి, ఖచ్చితంగా హెల్ప్ అవుతుంది. అదేవిధంగా కాంపిటేటివ్ ఎగ్జామ్ పర్పస్లో ఎంసెట్ నీటికి సంబంధించిన వీడియోస్ కూడా అప్లోడ్ చేయబోతున్నాం. ఖచ్చితంగా ఛానల్ని సబ్స్క్రైబ్ చేసుకోండి. ఓకే, లేట్ చేయకుండా టాపిక్ వెళ్ళిపోదాం. ఆ లాంగ్ ఆన్సర్ క్వశ్చన్ ఏంటి, ఎలా ఇస్తాడో చూద్దాం. ద క్వశ్చన్ విల్ బి లైక్ దిస్: డిఫైన్ ఎలక్ట్రిక్ ఫ్లక్స్ అప్లయింగ్ Gauss's law and derive the expression for electric intensity due to an infinite long straight wire. Define the electric flux applying the Gauss law and derive the expression for the electric intensity due to an infinite long straight wire. So children, this is a long answer question. The first thing is what is asking, what is electric flux? The number of field lines passing through the particular area in the field, that should be called electric flux. ఎలక్ట్రిక్ ఫ్లక్స్ ఈజ్ ఏ స్కేలార్. మనం ఎలక్ట్రిక్ ఫీల్డ్లో ఒక పర్టికులర్ ఏరియా ఆఫ్ ఎలిమెంట్ తీసుకున్నప్పుడు ఆ ఏరియా ఆఫ్ ఎలిమెంట్ నుంచి ఎన్ని ఎలక్ట్రిక్ లైన్స్ ఆఫ్ ఫోర్స్ అనేవి వెళతాయో, ఎలక్ట్రిక్ లైన్స్ ఆఫ్ ఫోర్స్ అన్న ఎలక్ట్రిక్ ఫీల్డ్ లైన్స్ అన్న రెండు సేమ్. ఒక పర్టికులర్ ఏరియా నుండి ఎన్ని లైన్స్ ఆఫ్ ఫోర్సెస్ వెళ్తాయో, ఎలక్ట్రిక్ లైన్స్ ఆఫ్ ఫోర్స్ అనేవి వెళ్తాయో వాటిని మనం ఫ్లక్స్ అంటాం. ఈ ఫ్లక్స్ అనేది స్కేలార్ క్వాంటిటీ. సో దట్ షుడ్ బి గివెన్ బై ది ఫార్ములా లైక్ దిస్. Look here, definition of flux: the number of electric lines of force passing through the particular area is called electric flux. Flux is a scalar and pi is equals to E dot A. This is the formula. Pi is equals to E dot A, and what do you write? Pi is equals to EA cos theta. When theta is equals to 0, flux is maximum. When theta is equals to 90, flux is minimum. So when we are taking particular closed surface, we can write the formula pi is equals to closed integral E dot ds. So this is the formula for electric flux. And next thing is here, before going to start the derivation of electric field intensity, we have to know about the what is linear charge density. Linear charge density. When we are taking particular conductor, on that conductor the charge distribution should be along the length, then that is called linear charge density. The charge distributed along the length of the conductor is called linear charge density, and that should be given by the formula lambda is equals to q by L. This is the formula, lambda is equals to q by L. Q is the charge and L is the length. Now linear charge density unit is what? Coulomb per meter. What is that? Coulomb per meter is the unit for linear charge density. So children, so this is simply about the electric flux and linear charge density. So electric flux అంటే ఏంటో తెలియాలి, linear charge density అంటే ఏంటో తెలిస్తేనే మనం డెరివేషన్కి వెళ్దాం. ఇప్పుడు ఆ డెరివేషన్ ఏంటో చూద్దాం. Now we have to derive the expression for electric field intensity in case of a infinite long straight wire. So children, look at the diagram very carefully. This is the one wire that should be having some charge, positively charged. The net charge, what you have to take, Q. The charge distributed along the wire should be taken as Q, and here to find out the electric flux we have to construct one Gaussian surface. This is the one cylindrical Gaussian surface. What we are finding with the dotted lines here, this is the cylindrical Gaussian surface. So what you are finding that in dotted lines, this is nothing but cylindrical Gaussian surface that should be having some radius r. Clear? So in that, here we are taking now, this is the like this. Here from that wire, in the diagram you have to observe, from that wire the electric field is acts radially outward. So this is direction of electric field radially outward, and this is the length of the cylinder. And now here we are taking like this, cylinder is here A, B, C, D. Clear? Now the element, the top of the cylindrical surface should be taken as ds1, and the top of the bottom of the cylindrical surface should be taken as ds2. This is ds1 and ds2. So you have to observe very carefully, children. ds1 and ds2, A, B and CD, that should be how they are with the electric field. ds1 and ds2 is in perpendicular to the electric field. So ds1 is in this direction and electric field is in this direction. So how much angle? 90. And similarly ds2 also same thing. ds2 is like this. This is the ds2, and the electric field is again, that should be goes like this. So angle is how much? 90. That's why here, according to the formula, pi is equals to what, right? EDS cos theta. When angle is 90, there is no flux passes through that one. There is no flux passes through ds1 and ds2. And what we are taking, cylindrical surface. This is the cylindrical surface what we are taking. Through that only the flux is going on. Through that only the flux is going on. Clear, children? So here, that is the flux here. The flux is passing through the only, yes, through the cylindrical surface only. So that's what, children, already what we know. What we know, children, that is the AC is there and BDD is there. Here what we are taking, linear charge density. Linear charge density. Linear charge density is what? Lambda is equals to Q by L. The charge distributed is along the length. Along the length, lambda is equals to Q by L, children. So taking that is the equation number 1. And what we are saying, there is no flux. There is no flux through the ds1 and ds2. ds1 and ds2. So what we know, flux pi is equals to closed integral EDS1. EDS1 we are taken. What you have to write? Pi EDS1 cos theta. E dot ds1, scalar product. EDS1 theta, cos theta. Already what you are taken? Here theta is equals to 90 degrees. Why? Because ds1 is in perpendicular to the electric field direction. So we have to observe the electric field is radially acts outward. So that's why here there is no flux passes through the ds1. And similarly we will write pi 2, that is the flux passes through ds2. So closed integral E dot ds2, that is what you have to write, closed integral EDS2 cos theta. Here also theta is equals to 90, since what we know, cos 90 is equals to 0. Cos 90 is equals to 0. Therefore pi 2 also 0. There is no flux passes through the ds1 and ds2. Therefore in this case, flux passes through the cylindrical Gaussian surface. Cylindrical surface. So what it is? Cylindrical surface, what it is? A, B, C, D. So what, right? Pi is equals to closed integral EDS cos theta. So in this case, the cylindrical surface is parallel to the electric field. Cylindrical surface is parallel to the electric field. That's why here what, right? Pi is equals to closed integral EDS cos 0. EDS cos 0. Then obviously what you have to write? Cos 0 value is 1. Then pi is equals to integral ds. So children, we need some space. That's why I'm erasing this one. So very simple, children. Flux ఎలా వస్తుందో తెలిస్తే మనం మిగతా మొత్తం కూడా ఈజీగా అనుకోవచ్చు. ఓకేనా? So look here. What we are writing? Pi is equals to integral EDS cos 0 we said. So then what you have to write? Obviously here pi is equals to E integral ds. Here cos 0 is 1. Then pi is equals to what, right? E into s. E into s. Here where s is the surface area of the cylinder, surface area of the cylinder. That should be what, right? S is equals to 2 pi RL. Then what you write? Pi is equals to E into 2 pi RL. So this is equation number 2. But according to Gauss law, Gauss's law, what you have to write? Pi is equals to Q by epsilon naught. This is equation number 3. Now we have to compare equation number 2 and 3. Look here, children. According to the derivation, what is the flux? Pi is equals to E into 2 pi RL. And according to Gauss law, what you have? Pi is equals to Q by epsilon naught. These two equations are representing the flux. That's why here we have to equate these two equations. Then what do you get, children? So here what we get? Look here, simply from those what, right? E is equals to E into 2 pi RL is equals to Q by epsilon naught. From that formula, what you have to derive? Electric field intensity. That's why remaining terms must be go to that side. We have to bring that side. So E is equals to Q by 2 pi RL epsilon naught. 2 pi RL epsilon naught. That's why here simply we are writing the same equation should be like this. E is equals to Q by L into 1 by 2 pi R epsilon naught. 2 pi R epsilon naught. Then Q by L is what, children? Already we discussed. Linear charge density is what? Lambda is equals to Q by L. That's why here E is equals to lambda by 2 pi R epsilon naught. So children, this is the expression for electric field intensity due to the infinite long straight wire. So what we are taken that wire, for that the electric field should be at a distance of R. సో మనం తీసుకున్నటువంటి ఏవైతే వైర్ ఉంటుందో ఆ వైర్ నుంచి మనకి ఎలక్ట్రిక్ ఫీల్డ్ అనేది ఎంత వచ్చిన ఫార్ములా E is equals to lambda by 2 pi R epsilon naught. So what is epsilon naught? This is the permittivity. What is permittivity in free space? And what is lambda? Linear charge density. Here what is R? Radial distance of cylinder. So this is about the derivation for children electric field intensity in case of a infinite long straight wire. So dear students, if you can understand this one, like, share, comment the video and subscribe our channel and suggest our channel to your friends also. Thank you.